during this test and for the final, really. And that would be very good for you. So there you are. This is going to be practice. Okay, practice test number 3. So the topics that you have to know from this one for the test, besides your quiz, are going to be the following. So the topics are going to be, the first topic is going to be definite integral. Definite integral. We repeat it again. Okay, this is where you don't need any, it's not going to be definite, sorry, I should say, okay, definite integral. Definite integral is new. This is where you use the integral of from a to b. You say that's the one, f of x dx. And if you want to find it, the formula is you find the antiderivative, and then it's going to be the difference between f of a and f of b. So this would be one important topics that we're going to use for the definite integrals. So on these topics, you are going to get the questions are going to be how we're going to evaluate it using the definition. Okay, so the first, we give you one question, finding definite integral. The first part is going to be by definition. By the definition. So by definition means you have to use this formula. A to b f of x dx, remember, is equal to the limit of the sigma of f of ci times delta x, I from 1 to n goes to infinity. And where this is where, or when delta x is equal to the b minus a over n, and ci is going to be any number, but we give you a formula. Ci is going to be equal to the a plus I delta x. Okay, I delta x, when I can be equal to the 1, 2, 3 up to there. So this is, one is just using the formula, the definition only. The other one, we give you one that using, so by using a fundamental theorem of calculus. The fundamental theorem of calculus is this one. So integral, you can use formulas here. F of x dx is equal to the f of b minus f of a. We give you two parts. The first part you don't need to use substitution method, but the second part you do need it to use the substitution method. Okay. So one with the definition, some easy one like 0 to 1 x squared, you know, the x, and you have one, we are going to check it. And I've already posted the extra point for you, extra 3, which is very good. You have these 6 topics on that one. So check that one too. Okay, so by definition, using the fundamental theorem of calculus. So this is going to be 1, 2 on these definite integrals. There is going to be another problem on this, remember, and that's introduction of the integral function. Integral functions, which is related to this theorem. What's integral function? Integral function is that if a function defined by an integral, like a to t, f of t dt, then if you want to differentiate it, this is going to be just f prime of x is equal to, you want to find the derivative of antiderivative of a function. The result would be simply the function. Okay, so you drop the integral, replace the t by x. Then you find the f prime, we may ask you to find the f double prime as well. Okay, so one question on the integral functions for this, okay, for this one and for the final. So this is definite integrals, okay? The other part is going to be the part from your quiz that we're going to repeat it, and that is indefinite. Okay, indefinite integrals. This is where you are not going to find the integral as a number, you are going to find it as a function. So you are going to basically, one group is you are going to use this formula, x to the n dx, the power rule is going to be x to the n plus 1 over n plus 1 plus the constant c. For the time being, this n is not going to be -1 because we need the natural log. Okay, so one question would be related to this, like in your quiz, and the other one, or a couple of them, are going to be related to the substitution method. Okay, so the other part for the indefinite integral is substitution method. Substitution method. For the substitution method, you know that you have to use the general formula, general power rule, and that would be u to the n du. This is going to be the problem that we usually using the chain rule to differentiate it. So again, this is going to be u to the n plus 1 over n plus 1 plus the constant c. Of course, n for the time being cannot be equal to the negative 1. Okay, then a couple of those trigonometric one that we are going to explain it during the, okay, when you go to root solutions. We are not going to give you any average value for this quiz, okay? So the average value is not going to be included. Okay, average, we give you this one on the final. Average value of a function. Remember the formula was the average value is equal to the 1 over b minus a, integral from a to b, f of x dx. Okay, this is not going to be applied for the time being. And that's it, 6 questions of this on this test and on the final. Okay, you can keep it, even for your final. That gives you the idea of what you should emphasize for the second part of this test. And I'm going to do it exactly as I put it over here. Okay, we already done the indefinite integral, but I'm going to check it again to make sure that you're happy about it. Okay, so get the topics and study. You don't need anything else. If you check the extra 3 that I gave you, exactly you will see these questions. So that would be very good for you. You get a 5 points, remember. You get a 5 point extra for it, and it would be good for this test and for the final. Okay, so that's the plan. Now, how we're going to get this plan? So the first group of the problems that we have are going to be indefinite integral. Okay, so this is the practice test, question number 1. Question number 1, we asked to find each. Okay, find each. They are indefinite. Even if we say integral, you have to know it yourself. Okay, I'll put this one in parentheses. So find each indefinite integral. Okay, there are going to be 2 groups. The first group, some of you missed it. The problem on the quiz was similar. Part 1, this is it, integral of 10 x to the 4th. Okay, minus 8 over x to the 5th. Okay, x to the 5th minus 2 dx. This is part 1. You see what we're going to do. The first thing to do is check to see if you have to rewrite it. We know that we have only the power rule to take care of this. So if there is going to be any radical, you are going to rewrite it. If there is going to be anything down the denominator, you are going to move it up. So we have to rewrite it first. Okay, so this is it. Solution. Rewrite is going to be integral of 10 x to the 4th minus 8 x to the negative 5 minus 2 dx. Now, action of integration. Action of integration, we add 1 unit to the power and we divide. So 10 is a number, keep it. X to the 4th, power up, x to the 5, 4 plus 1. You see, this is your formula. Okay. So x to the 5th over 5 minus 8 x to the negative 5 plus 1, negative 4 over negative 4. Okay, minus 2 This is like 2x to the 0. So when you move up the power, that gives you minus 2x and the constant c. You simplify and you are not going to live with any negative power here. So again, simplify these two, so that give me 2. Okay, 2x to the 5th, and negative would be positive here. 8 and 4, that give me 2, so we get a fraction bar. On the top is going to be 2, and you bring x to the 4th down. X to the 4th, okay, minus 2x plus the constant c, and then you're done. Okay, so this is going to be the result of the integral. Any question? Most of you did well this one on this quiz, but why not? You should be able to do it again. That's the part 1. Question part B. That's the special, and this is the one that you missed, some of you on this quiz. So it's integral of, okay, kind of a fractional one, 12 plus 5x, okay, 5x minus 3x squared, then divided by x to the 4th, x to the 4th dx. Okay, that's the one. So as we talk about it, you have a fraction here, so x to the 4th is down the denominator. So what you have to do, you have to move it up. I told you that you move it up and you multiply by everything on the top. Some of you missed it. You just multiply by one of the term on the top. So a solution is going to be, we rewrite it, we bring x to the 4th to the top, x to the negative 4 times 12 plus 5x minus 3x squared dx. Let's see, that's 1. So what we are going to do, we are going to multiply it inside. Okay, you multiply it inside, that give you integral of 12x to the negative 4 plus 5x to the negative 4 plus 1, which is a negative 3, minus 3x to the negative 4 plus 2 would be a negative 2. Negative 2 dx. Okay, you make sure you multiply by everything inside. Now integrate. Action of integration, 12x to the 1 up, negative 4 plus 1, negative 3, over negative 3, done. Plus 5x to the 1 up, negative 3 plus 1, negative 2, divided by negative 2, and you're done. Minus 3x to the 1 up, negative 1, plus the constant c. Simplify if you can, and then rewrite it. So that gave you a 4. So the result would be, you get a fraction bar. There is a negative sign, negative 4 on the top, x cubed on the bottom. No negative power in your answer, remember. Over here, positive negative would be negative. Get the fraction bar, 5 on the top, 2x squared, done. Next, negative, positive. Positive, get the fraction bar, 3 on the top, x to the negative 1 down, x plus the constant c, and you're done. Okay, so pay attention. Again, most of you did it all right on the quiz, but some of you didn't use parentheses and you just multiply by one term, so it's not correct. Okay, so this is a very popular case for the indefinite integral. Any question? You have one more. We did it before, but I'd like to explain it again. Integral of x plus 1 over x dx. Oh, I'm sorry, over a radical x. Radical x. It doesn't matter, radical x. You know that you have to rewrite it, rewrite the radical first. So it's going to be, so this is the solution. This is going to be x plus 1. You rewrite the radical, that gives you x to the half dx. Now you have to bring x to the half up. X to the half is going to be x to the negative 1/2. Again, parentheses, x plus 1 dx. As we did it for the other, but you get some fraction, doesn't matter. You multiply inside, of course, when you multiply, you add the powers. So this is going to be integral of x to the negative 1/2 plus 1. Negative 1/2 plus 1 would be x to the positive 1/2. And this would be plus x to the negative 1/2. Negative 1/2 dx. Okay, when you multiply, remember you add the exponent. Now action of integration, move up the powers. X to the 1/2 plus 1 is like 1 plus 2 would be 3. 3/2 and the 3/2. Okay, next plus x to the negative 1/2 plus 1 is a negative 1 plus 2 would be 1, 1/2 over the 1/2 plus the constancy. Of course, you have to use the reciprocal to bring these numbers up. You flip it if you like. So that gives you 2/3 x to the 3/2 plus 1/2. You flip it, that gives you 2. 2x to the half plus the constancy, and then you're done. Some people, they change these fractions into the radical. It's up to you, but you don't have to do it. No negative power in your answer. That is the only restriction that we're going to impose. Okay, any question? So this is going to be a kind of the first type of the integrations that we're going to have. There's one more. Right? So in this type, you may get something like this, or you may get, a couple of radicals, something down the denominator as in your quiz. So just check the quiz again and just get a similar one. I have one more. So I check that one too. So we have the complete solution. So the part D, you are going to integrate in this one, 2 over, okay, cube root of x, cube root of x plus x cubed plus 7 dx. So what is special about this one? You have the radical here. So we change the radical x to the 1/3, but then we move it up. Some of you missed this one on the test, on the quiz. You change the radical, so it's going to be x to the 1/3. But when you move it up, it's going to be x to the negative 1/3. Some of you missed that negative one. Check your quiz. And if you did it, make sure you're not going to. That's why I write it down twice. But you can do it right away. It's x to the 1/3. Okay, plus x cubed plus 7 dx. Now move it up. That gives 2x to the negative 1/3. Okay, negative 1/3, and that would be x cubed plus 7 dx. Okay, so if you do it right away, make sure it's a negative 1/3. Then the rest is easy. It's going to be 2 times x to the is a negative 1/3 plus 1. It's like negative 1 plus 3, which is 2. So that gives it 2/3. 2/3, okay, over the 2/3. Then x cubed, it's easy, move up, x to the 4th over 4. 7 is like 7 times x to the 0, so the integral would be 7x and the constancy. Okay, you have to take care of this, use reciprocal. It's going to be 2 times the 3/2, okay, x to the 2/3, and that would be x to the 4th over 4 plus 7x plus c. 2 and 2, you can simplify it. So your final answer is going to be 3x to the 2/3, okay, plus x to the 4th over 4 and plus 7x plus c. Final answer. Any question? So
I had a question
yes,
about, I think it's most like example B, but
yes,
from the quiz.
yes.
Um, I was confused on that question because I think we do end up with an x to the negative 1.
Oh, yeah. That was a kind of a mistake or just typing error, if you like. But I gave the point for that one, and that would be natural log ln x. I saw some of you just got the result. In your book, they talk about something like x to the negative 1 in future. So you are not going to see it on this test, but we are
Okay.
going to give you to the final. You see, this formula is a nature of your book that we are going to arrive at this later. You see, this is the one you got. This is the one that you have. you end up with this one. See, of course, you cannot add the 1 that gave you x to the 0. So when we get to the next chapter, we change to the 1 over x over dx, and we want to find a function whose derivative is 1 over x. That function is ln x, at L natural log of x plus c. So since we follow your book, we shouldn't have this one. But you will see it on Monday. We introduce this function. Okay.
So
But
does that mean that that question doesn't,
no,
like,
no,
did
no,
we
no,
miss
no,
points for not being able to solve
no,
that one?
no, no, nothing.
Okay,
So if you missed that part, I didn't take out any point. I
okay,
saw some
thank you.
of you just write it down as is, so I give you the point. And some of you use the natural log, I give you the point. Because, you know, I just find out when I was grading it. So that's it. But this would be part of the final quite a lot. As
Okay,
you can see,
thank
we try not to have it at the moment. But some of these practice one is the one that I usually give to the university. Over there, we learn this type of function at the beginning of the course. But with your book, the Larson, we learn it at the end. So you're not going to sit on the test. I double check that one to make sure that we don't have it. Okay, any question? So it's going to be just usual business of these, the one that you have, you know, one question, 2 parts, similar one. Okay, so that is our first topic. Any question? This is a definite integral with no substitution method. So we are going to have another group with the substitution method. And that's why I go with to the number 6 first to do the substitution. Then I come back and continue. Make sure we have enough time to do the second group. Okay. So this is the order that you are going to see it. Okay. Or what's that? Yeah. Or we can go on, you know, just because I think we would have time to do it. Okay. Let's go to the second one. The second question is kind of a differential equation. And most of you did this one very well. So it would be, shouldn't have any difficulty to do it on the test. So this is question number 2. Question number 2 was the type that, you know, the function was given to you. Want the derivative of the function was given. You've been asked to recover it. So I'm going to call it solve each differential equation. That's the expression. Differential equation, or just the functions, you know, find the functions. And so the first one is given as, is the one is a dy dx, which is y prime, which is f prime. It's equal to the 8x cubed minus 4x minus 1, with the condition that f of 0 is equal to 1. Okay, this is the way you are going to see it in science, because this is going to be rate of change. So rate of change of a function is given. You want to recover the function. Since when we integrate, we add the c, so we have many solutions. But if they are going to be interested in only one solution, they give you a condition. So this means you are going to check this condition here, replace x by 0, let it to be equal to the 1 to get the c. And this is the one that mostly did all right on the test. Okay, so this is it. So we switch this notation first. We switch it into the f prime of x equal to the 8x cubed minus 4x minus 1. Okay, now it's like the derivative, antiderivative of the function is given to you. Want to find function, you need antiderivative or integrations. So this means f of x is simply integral of 8x cubed minus 4x minus 1 dx. You go and find the antiderivative of the function. There is no radical, no rational expression, so we can go ahead and find it. So 8 is a number, move up the power, x to the 4th over 4. Okay, minus 4, x squared over 2. And you know the negative 1 would be negative x, because it's x to the 0. But a constant c. We simplified first, so our f of x so far is going to be equal to, these two would cancel out, that give you 2, which is a 2x to the 4th. Okay, and these two would cancel out, that give you minus 2 x squared, and this is a minus x plus c. You see, this is a kind of, we call it general solution, because that's a constant c. This is not one solution, it's infinitely. Again, you can replace c by any number you like. But you have a restriction. Initial value is, we call it initial condition. So you need to find the one that satisfies this condition. So we continue, we say, oh, f of 0 is equal to 1. So this means you go to this equation, replace the x by 0, and let it to be equal to 1. 0, 0, 0, 0. So you get a 0 plus c equal to 1. So your c would be 1. So you have to repeat your function. So the final answer is 2x to the 4th minus 2x squared minus x plus c, which is 1. So this would be the final answer. Okay, we say this is a unique solution because you just find a specific one. Okay, so this is going to be the type 1 that we have. Any question? So we give you 2. The other one is a kind of fractional one, like those integrals that we did. Are you ready? Getting the second one? So explain the second one. Again, the one that you did have, the second part was f double prime. And you did very well, because when we say f prime is velocity or the moving object, f double prime is acceleration. I'll just give you that one, is the type that we do in calculus 3, but probably on the test, I don't remember, but you may not have that f double prime. But we check this second type that we're going to be interested in. Okay, so that was part 1, and this is the part 2. The part 2 is going to be fractional, so it's a dy dx, which is equal to the 1 minus 2 over x squared, okay, plus 5 over x cubed, and the initial condition of f of -1 equal to 2. Okay, again, switch the notation into the f prime. That give you a better idea of with the notation that we did have. Okay, so solution, we go with the f prime. So that would be f prime of x, which is equal to what? 1 minus 2 over x squared, and the plus 5 over x cubed. That's the f prime. So f prime is given to you. You want to find the f, it's antiderivative. You have to find the antiderivative or integral, indefinite integral. So f of x would be just the integral of 1 minus 2 over x squared plus 5 over x cubed dx. Okay, so that is going to be our result. So we want to integrate it. You know that you have these fractions here. So you have to move them up. So it's going to be equal to the 1 minus 2x to the -2 plus 5x to the -3 and the dx. Okay. Now, action of integration. You know that the 1 is like x to the 0. So the integral would be x minus 2 up, move up the power, x to the -2 plus 1 would be -1 over the -1 plus 5 x to the -3 plus 1, that gives me -2. -2 over -2. But remember the constancy. Any question? So double check your powers, when it's a negative number to make sure you get it right. Now we have to check those, negative powers, reverse, rewrite. So this is it. So f of x is going to be, this is x, negative would be positive, the sign is positive, fraction. You put the 2 on the top, x to the -1 down, so that gives you x. Okay, then positive, negative, fraction, 5 on the top, 2 down the bottom, x squared. And the last one is just a constant c. So this is going to be your general solution. Any question? So you will have some fractions or some radical expression. And now we have initial condition. Initial condition is f of -1 equal to 2. So you have the f of -1 is equal to 2. So you're not done. We have to continue. So this is how we continue. We say, oh, this means I can put x equal to -1. Then I let whatever I have equal to the 2. So carefully, -1, it's a -1. 2 over -1 minus 5, 2 times a -1 squared plus the c, and this must be equal to 2. Equal to 2. Okay, carefully substitute and continue to find it. This is just a -1. Positive negative would be negative, so that's -2. And over here, -1 squared would be just +1, so that gives you 5. Okay, 5 over 2. And the plus c equal to 2. Okay, you have to solve for c. So for example, this is going to be a -3 minus 5/2 plus c equal to 2. So the c would be 2 plus 3 plus 5/2. Okay, 2 and 3 would be 5. So it's going to be 5 plus 5, 5/2. You find the common denominator, which is 2, 10 plus 5, which is 15/2. So this is going to be your c. So c would be 15/2. And you're not done. You have to go back and substitute for the c, give us the function. So the final answer is this one, f of x equal to the x, 2 over x minus 5 over 2x squared plus 15/2. So this is going to be a function that satisfies that condition that you have. Again, in application is a rate of change of a phenomenon, something that experimental work, something that you've already done, and then you want to find the actual model, we call it, actual function to get this true. Okay, any question? So that would be the second topics that we talk about, or the second question. Now we did have one more method to take care of this integral, and that method is a substitution method. So I do the substitution method first, and then we come back and we do that definite integral. Okay, we stay with the indefinite. Are you ready? So I'm going to get all the substitution first. This is question number 6, the last question that we have. So I do it in this order, so you know what's going on. So that was a definite integral. Indefinite. So number 6. Number 6, integrating by substitution. Okay, integration or integrating by substitution. Remember, you're integrating the function type. It's going to be a function that the type of function that we use to differentiate using the chain rule. Now we want to integrate it. We talk about it, the formula is going to be just like the chain rule that we had. It is going to be a function. There's going to be a parenthesis, something we call it u. So this is the formula that we're going to use. Integral of u to the n du. It's like when you find derivative of u to the n. It's going to be simply u to the n plus 1. Okay, over n plus 1 plus a constant c. Again, n cannot be equal to -1, but it's going to be next week when we get to the final. That gives us the natural log. In this form, and the substitution method is the du is going to be u prime dx. You see, this is what you have to know. So what you are going to do, you are going to use this substitution u for whatever it's inside the parentheses. You call it u. So you always end up with u to the n. Okay, but you have to see your integral would be given in terms of the x. So we get the dx in the integral, but you have to change it into the u du. So what you have to do is you find the du, you prime the dx, and from here you find the dx. You see, you form this. As soon as you form it, then you get the dx, you come back and then do the job. So as soon as you do the substitution, it's nothing new, just action of integration. And action of integration usually add 1 unit to the power and go. Okay, so there are kind of 4 possibilities. So we give you 2 questions and we check all the 4. When we get to the final, there are going to be 6 possibilities. So we get 3 questions on the final, 3 and 6 functions to integrate. Okay, this is how we are going to do it. So this is it, and we have all of them here. The first one, type 1. Type 1 is just going to be a power function, but it may be a radical function. You see, that's one. Integral of x, the square root of x squared plus 9 dx. That's it. That's type 1. It's not a rational function. It's not trigonometric. This is the type that you will see. So you know that in calculus, whatever you see the radical, we change it. So switch this radical first. Okay, so the solution is going to be switching. So if you switch it, you get x times x squared plus 9, everything to the half, dx. You see, you get a parenthesis raised to something, you have to use substitution method. You take this one to be u, okay? So you get u to the 1/2. So your target is going to be, you see, to find this one. As soon as you take this one to be u, your target is this, u to the 1/2 du. So you have to form this one. As soon as you form u to the 1/2 du, you can use the formula. It's going to be u to the 3/2 over 3/2 and into that, okay? So as soon as something inside the parentheses, you call it u, this must end up with this one. Now you do the procedure and you have to explain the details. Otherwise, you won't get point for it. Okay, this is it because it's a substitution method. So you have to substitute and show us. So this is the procedure. You take the u to be x squared plus 9, step 1. Then you find the du. du. You see du is you differentiate, you multiply by the differential of the x. Derivative of x squared plus 9 would be 2x times dx times dx. Now you solve for dx. You divide by whatever leftover is here. So the dx is going to be equal to the du over 2x. You do this one for all the problems of the substitution method. Any question? So make sure that you do it and write it down for us. Now you go back and substitute. You have to substitute to get this one. Again, you have to show your operation. So this is x times x squared plus 9 to the 1/2 dx is going to be equal to, you don't have anything for the x, don't worry. This is u to the 1/2, and then you substitute for dx. Okay, so what is going to be your dx? Multiplied by dx is du over 2x. All the x's must disappear if you have done your job right. So this x and x will then cancel out. The leftover is a 1/2, a constant. When it's a constant, you can pull it out. 1/2, so it's going to be 1/2 out. It's going to be 1/2 integral of u to the 1/2 du. That's exactly your target. If you don't get this target, probably you miss something. Okay, so the only thing that you may, extra thing that you may have is this constant term, 1/2. 1/2 is a number, you can put it out of the integral. Now, action of integrations. So it's going to be equal to the 1/2 u to the, like the power rule that we did before. 1/2 plus 1, 3/2 over the 3/2, but the constancy. But you have to simplify, that you have to multiply this one by the reciprocal, 1/2 times You flip this one, you said 2/3, and the u to the 3/2 plus c. So you simplify it, you simplify these two, so that gives you 1/3 u to the 3/2 plus the constant c. But you have to change into the x because the function was in terms of the x. So the final answer is 1/3. You substitute for u. U was x squared plus 9. So it's x squared plus 9. Okay, x squared plus 9 to the 3/2 plus the constant c. This is going to be the final answer. Any question? It's very a standard operation and it can be done easily. So double check it. You don't have to rewrite it, but I rewrite it to have a record. X radical x squared plus 9 dx is equal to the 1/3 x squared plus 9 to the 3/2 plus the constant c, and you're done. Any question? So this is one method. I talk about one shortcut. You can do it if you can operate it, but this is a very safe method. I do that one too in case you want it. Okay, but you have to explain it as I write it down here. So this operation can be done in short term. The thing is going to be when you want to switch, you see, when you want to get to this u to the 1/2 du, according to the chain rule, you see, you have to have the u prime here. U prime dx, you pair them together. U prime and dx, you pair them together, that give you du. So if you already got this pairing here, so you can do it right away. You see the shortcut or the second method is going to be, this is the way I do it. If you take calculus 2 or 3, it's the way we do it quickly over there. It's not bad. This is good, very safe. You can do it, but in case you love, a different method, this is it. So in this method, this is going to be x times x squared plus 9 to the 1/2 dx. So you have the pair u prime and the dx together. This is u. You have to look for the u prime. U prime would be 2x. You have the x here only. So a 2 is missing. So you have to create the 2 yourself. So what we do, we divide by 2 and we multiply by 2, you see? Because these 2 would cancel out, so you haven't done anything wrong. So that would be x squared plus 9 to the 1/2 dx. Now this is u, and this is u prime. So the pairing is possible. So what you do, you pair these 2 together. So that gives you 1/2 integral of x squared plus 9 to the 1/2 times it by 2x dx. You see? Automatically you get whatever we did over there. So this is u, this is du. Since you pair them together, you can use the power rule right away. Power rule, you add 1 to the power. So it's going to be equal to the x squared plus 9. 1/2 plus 1 would be 3/2 over the 3/2 plus the constant c. You flip it, okay, I missed something. This is 1/2 here. 1/2 here. You flip this one and you simplify it, that gives you 1/3 that you got over here. Okay, so it's going to be 1/3 of the x squared plus 9 to the 3/2 plus c, and do that. That's actually what would happen for this method of substitutions. So in this one, it's the same method, but you don't, you don't rewrite it if you like. Okay, you can do it if you like, and even if you don't use it, just keep in mind for your future if you want to take calculus 2 or calculus 3, because the substitution method, you may have to do it over and over and over in one problem. So when we get a little bit more experience, we make it short, especially on those ideas of the calculus 2 or 3, but that's optional. Okay, any question? That's safe. Always give you the result right away. So that is the type 1, just a kind of a radical. What is going to be type 2? Type 2 is going to be a rational function. So we give one from each, part B. Rational function will be two types in future because of those integral 1 over x that I talk about it. But you don't have it, and we stay with your book. So we stay with the problem that you are not going to get those something like 1 over x. Okay, there you are. Rational function, x plus 3. And the bottom one is x squared plus 6x, okay, plus 1. All cubed dx. For the rational function, as usual, we change the radical and we change the rational expression. So move it up, rewrite it, carefully rewrite it. So what's going to be the solution? If you rewrite it, you move this one up, that gives you x squared. That's x plus 3 times x squared plus 6x. 6x plus 1 to the negative 3 dx. That's it. So it's ready for the chain rule. Inside the parentheses, you call it u. So your target is, so this is the missing one. So you see your target is you change it to the u to the negative 3 du. That's the target. That gives you a plan that you're going to have. Okay, always, whatever is inside the parentheses, you call it u. So you must end up with u to the negative 3. Okay, now check to see if you can get that. So you have to work on it. That's a u, x squared plus 6x plus 1. That's your u. Du, simply the derivative. If of x squared 2x, 2x plus 6. 2x plus 6. Okay, so that gives it 2x plus 6, of course, dx. And then you have to find the dx. So what's going to be the dx is equal to, you have to divide by 2x plus 6. So that gives you du over 2x plus 6. So this is the preliminary operation that we have to do. Any question? Go back, substitute. You go back, substitute. And if you do everything all right, you should get this one. Okay, substitute. If you don't want to repeat this one, we can call it I, the integral. So it's going to be, this is the one. So we substitute, it's going to be integral of, you don't have to substitute anything for x plus 3, don't worry. You hope to be able to simplify it, of course. The inside, you call it u. This is your u to the negative 3. But you multiply by what? You multiply by dx. What is your dx? So your dx is du. Okay, divided by 2x plus 6. You know, you don't need that, but you can use it, a princess here. You see, you have to simplify this, otherwise you can't do it. You need, the target is this one. So how are you going to simplify it? Sometimes you need a little bit of algebra. This x plus 3. So it's a 2x plus 6. So you can factor out the 2. You see, if you factor out the 2 here, so that gives you 2 times x plus 3. Now the x plus 3 and x plus 3 will cancel. It must be canceled out. Otherwise, you know, you have to check to see where you made a mistake. So what's going to be the leftover? Leftover is 1/2. 1/2. You take it out, you get your target. So this is going to be equal to the, okay, is equal to the 1/2. It's going to be equal to the 1/2 integral of u to the negative 3 du. Any question? So you may have to do a little bit of simplification, the algebra part, to be able to do it, but you already set your target and you know what you are looking for. Now that's it. Action of integration, you just add 1 unit to the power. So this is going to be equal to the 1/2. Okay, u to the negative 3 plus 1, which is a negative 2, over the negative 2 plus the constant c. Simplify, this is going to be the sign, so we multiply this together. So this is going to be negative. Okay, negative, this is the top. Is going to be 1. The bottom one, 2 times 2, 4. And you bring the u squared up. So this is it. But you're not done, of course. You have to substitute for u. So it's going to be negative 1 over 4 u. U is x squared plus 6x plus 1. Everything is squared plus the constant c, and that would be your final answer. Any question? You don't have to, but I make a record here that it's x plus 3 over x squared plus 6x plus 1 all cubed, and we integrate it, and this is going to be the final answer. 4 times x squared plus 6x plus 1 all square and the constant c, and you're done. That's a best case when when it's a rational function. Most of the time you don't need this factoring, but be prepared for it. That's why I give you this one, so be aware of the the case that you may have to get these factoring to get through it. Okay, any question? So that's a type 2. So for the time being, these are the only types that we're going to have because we don't have the natural log and exponential function. So that's part B. And part C is like the part, we just repeat this in these examples that we have because we don't have much of these. Okay, so we have only 4 possibilities. So I do the C as well. It's very similar to the one that we did. Okay, you want to integrate this one, x squared radical. This is going to be, there was a misprint somewhere, but this is all right. It's a 2x cubed minus 1 dx. Again, you know that we switch the radical first. So we have to rewrite it. If you rewrite, it's going to be x squared, and we get the 2x cubed minus 1 to the 1/2 dx. That's it. Again, there is something inside the parentheses. We call this one u. So if you switch it, okay, so your target is going, you must get u to the 1/2. So if you rewrite it, do the substitution or write, you must get this one. Okay, you set up your target so that you know what you are looking for. Okay, of course, you know that then it's going to be u to the 3/2 over 3. So go for it. Take the u to be equal to the 2x cubed minus 1. That's a u. Differentiate. Differential of the u, du. Derivative, easy. 3 times 2, 6, 6x squared. Dx. And you have to find the dx. Divide by the leftover. So the dx is equal to the du over 6x squared. Go back, substitute, everything must be cancelled out, simplify, and you must get this one. No x here, remember. So that's it. We bring this one down. You can call it I if you don't want to repeat it. So it's going to be equal to, you don't have anything for x squared, so we just repeat the x squared. Inside is u, so it's going to be u to the 1/2 times the dx, and this is the dx times it. That gives you du over 6x squared. Okay, then x squared and x squared we cancel out. Left over 1/6. So pull out the 1/6. So that gives you 1/6. Okay, that's it. It's going to be 1/6. 1/6 integral of u to the 1/2 du. Okay, as we talk about it, as we plan. Now, this is it. So it's going to be 1/6 u to the 1/2 plus 1 3/2 over the 3/2 plus the constant c. Okay, we're done. We're not done. We have to simplify it. Use the reciprocal to bring it up and simplify. So this is going to be 1/6 That's a 3/2, that give you 2/3. Okay, 2/3, and this is u to the 3/2 plus c. You get a chance to simplify this 2 and 6, so that gave you 3, that gave you 1. The top would be 1, the bottom one would be 1/9. Okay, so this is going to be equal to the 1/9, and then u to the 3/2 plus c. Now we can substitute for u. You must substitute for u. Remember, u was 2x cubed minus 1. So this is the final answer, 1/9, 2x cubed minus 1, everything to the 3/2 plus the constant c, and then you're done. Any question? So that's going to be bad. If you want to do it, I do the short form for this one too, because it's a little bit different, just to show you. So if you like that method 2, you have to match the u prime and the du together. So we have to rewrite it. This is the rewriting. X squared 2x cubed minus 1 to the 1/2 dx. This is u. You have to look for the u prime here. U prime would be 6x squared. 6x squared. You have only x squared. So a 6 is missing here. You see a 6 is missing. So you create the 6. So how are you going to do it? You divide the outside by 6 and you multiply the inside by 6. You can only do it with the numbers. And that gives you 2x cubed minus 1 to the 1/2 dx. Okay, any question? You see any number you like, you can create it, because 6 and 6 would cancel out. Now we have the pairing. This is u, this is u prime. So the pair u prime and the dx together to create the u, du. So you have to rewrite it, switch it. So that gives you 2x cubed minus 1 to the 1/2 times it by what? Times it by 6x squared dx. You see, if you call this one u, this is exactly du. So it's like u to the 1/2. You know that u to the 1/2, you add the 1 to the power. So it's going to be u to the 3/2 is going to be equal to the 1/6, 2x cubed minus 1 to the 3/2 divided by the 3/2 plus the constant c. That's it, like exactly that you did. So use the reciprocal. So this is going to be 1/6, and that would be 2/3. Okay, 2/3, 2x cubed minus 1 to the 3/2 plus c. So as you can see, same thing. This 2 would be simplified, you get 1/9. So the final answer is going to be equal to 1/9, 2x cubed minus 1, everything to the 3/2 plus the constant c, and you're done. Same answer. Okay, it's the same method, but you just, as soon as you pair the u prime and the, okay, you pair the u prime and the dx over here, okay, then that give you the du. Automatically you have it. So you know what you are doing. You are doing u to the 1/2 du, because the action of integration is always you add 1 unit to the power and you divide. But it must be consistent with the u that you have over here. Okay. Again, it's a nice method, but you'll get it out. That's a safe, always you have it. But it's not bad to know, again, for future if you want to take those courses. Okay, so this is the radical one. Any question? So all the other one are just the repetition of this one. Okay, so let's give a break now. We come back, I do all of them for you, but it's just 2 cases, 3 cases. But when we do the next week natural log and exponential one, we're going to have some very, very nice one too. But for this test, these are going to be okay. It's a 9, almost 9:10. So we have around 15 minutes for your break, and we come back and we continue. We do the substitution, and then we go to the definite integral and the integral function. Okay, so see you then. Okay. So there are a couple of more. I'm going to explain it, especially the next group for the substitution method. Okay. So the next one is just check to make sure we get a correct one. It's kind of a trigonometric one. I have two different lists here. I want to make sure you get it right. Okay. So the next one is part D. Is a kind of, you can have some trigonometric function at the same time. Okay, so we continue with the method of substitution. So that's part D. And the part D, you want to find this integral of secant of x, okay, tangent of x on the top. And on the bottom, you have a secant of x plus secant of x plus 1, everything to the 10. Okay, dx. Again, as you can see, it's a fraction. So for the fraction, you have to move this one up. So you have to rewrite it. Okay, so the solution is going to be, when you rewrite it, you move this one up. So this is going to be integral of, you already got the secant of x, tangent of x on the top. Okay, and you move this one up as well. So that gives you secant of x plus 1 to the 10 dx. So again, something inside parentheses, we are going to call it u. So if you do everything all right, you must arrive at the, okay, so the target is going to be u to the 10 du. Can be easily created. So you take your u, which is your secant x plus 1. Okay.
Moving up secant.
Oh, yeah, yes.
Okay, yeah.
Negative. Thank you.
Thanks.
Good. Okay. And this is going to be negative 10. Thank you. So we get the differential of the u. Differential of the u. Derivative of a secant is secant x tangent x. Okay, but remember the dx. So we have to find the dx. We divide by the leftover here. So our dx is going to be equal to the du divided by secant of x tangent of x. Okay, this is what we have. This is going to be our dx. So go back, substitute, you get the u to the negative 10. So we are going to call this one I to repeat it again. So this is going to be integral of, you keep the secant x tangent x as is. But this is the one they call it u, so that gives you u to the negative 10. But remember, you have to multiply by dx. So it's going to be a dx. Your dx is going to be du over secant of x tangent of x. As you can see, these two would cancel out. So you end up with integral of u to the negative 10 du, as you predicted. Okay, so you get your target, and now you move up the power. Is a negative 10 plus 1, which is going to be negative 9. So it's going to be negative 9 divided by negative 9 plus the constant c. You have to rewrite. This is going to be the sign of the fraction. So the top would be 1, the bottom one would be 9 u to the 9 plus the constant. Okay, plus the constant c. Plus the constant c. Now we substitute for the u to finish it. So it's going to be minus 1 over 9 times u is secant of x plus 1 to the 9 plus the constant c, and then you're done. Okay, so it's not a big deal. In the short form, this can be done quickly, but it's not bad. It's very popular, the 10 with the secant, okay, the tangent, they put it here, sine, cosine. So, the other possibilities are going to be of this format, okay, and you have a couple of more with this fractional one. So that's a part D. The other group that we listed are all almost the same. Okay, so these are going to be the part D. I just list them, just explain it quickly, then you repeat it, you will do it yourself. The part E is just a repetition of the top, so it's going to be 2x times x squared plus 1, okay, to the 4th dx. That's easy. I just give you the final answer, then you repeat it, check it yourself. You see this is going to be u. So the target is going to be, you must get u to the 4th du. So you simply get the u equal to the x squared plus 1. Okay. And the du would be 2x dx. Okay, quickly, let me just finish it. So the dx is the du over 2x. If you go substitute, you easily get u to the 4th. Okay, so I repeat it. This is it. That's a 2x. So this is going to be u to the 4th. And the dx is du over 2x. So this two would cancel out. We get the target. U to the 4th du. Okay, so you integrated it into the u to the 5th over 5 plus the constant c. And then you, of course, substitute for u, x squared plus 1 to the 5th over 5 plus the constant c. And u. Okay, so all of them are mostly the same. Any question? There are a couple of trigonometric one. I'm going to explain that one. So that's part E. To get so this is it. Part E, part F. Just write it down, then you finish it yourself. Part F. Part F is this one. It's a 4x cubed. And you have x to the 4th plus 1 everything squared. And dx. You know that it's a fraction, so we have to move it up. If you rewrite it, so if you rewrite it, that gives you the following. You move this one up, so that gives you 4x cubed times x to the 4 plus 1 to the negative 2 dx. I'll do this one with the short form for you. You see if it takes outside the u. So you must get u to the negative 2 du. You see, if you do, you can continue with this one if you like. You repeat it. That's going to be u is x to the 4 plus 1 again. Then you continue to get that. But you see the du, the u prime, if you like. You see u prime would be, let's write it down. Okay, I do it. So that would be simply 4x cubed dx. You see, you already can match them together if you want to use the short form. But if you don't want to use the short form, it's going to be just a dx, which is the du over 4x cubed. If you go back and substitute 4x cubed and 4x cubed would cancel out, and quickly you get your result. Okay, so we get a 4x cubed here. That's a u to the negative 2, and the dx is what? Dx is du over 4x cubed. This would cancel out. You get the target, u to the negative 2 du. Okay, move up the power. So that would be u to the negative 1 over negative 1 plus the constant c. You bring it down, it's going to be negative 1 over u plus c. And you substitute for u, it's 1 over x to the 4th plus 1 plus the constant C, and then do that. Okay, these are all these type. The one type only is missing. We do it next week when this is 1. If it's going to be 1, we can't use the power rule. We have to use the natural log, but we talk about it before the final. Okay, so they are all the same. So that will take us to the one that I'm interested in. This problem is from your book, so I want to make sure you have no difficulty. Part J is very popular. It can come. It's a. Let me write it down so we can see it. You see this problem? This is the new type of that was the type 3, if you like, that we have. You see this one? Remember, we can, if it was secant square of x, secant square is derivative of tangent. But it's not secant square of x, it's secant square of something else. We talk about it when it's something else. You are going to call this inside to be u. So you call this inside to be u. You see, if you call this one, let me rewrite it to explain it. You see, this is going to be 1 over x squared. It can give you sine of 1 over x, cosine of 1 over x. In future, tangent, not down. So this is a situation they're going to have. That's our type 3. So we take this one to be u. If you take this one to be u, the target is going to be secant square of u du. We know that secant integral of the secant square is tangent. And then you'll be able to do it. Okay, so if it's anything other than the x, you call the inside to be u. Then you change. If it's going to be sine u, we end up with the integral of sine u, integral of cosine u. Okay, so you must know this one, that your u would be 1 over x. That's u. Again, you have to find the du. You can use the quotient rule. Derivative of the top times bottom would be 0. Bottom is 1, so that gives negative 1 over x squared. Then the dx. But we have to find the dx. To find the dx, we cross multiply. So that gives the dx equal to the negative x squared du. So that's what we want. Any question? Go back, substitute. This x squared and x squared would cancel out. We get the secant square of u. Okay, so this is it. We bring it down. We call it I. So integral of 1 over x squared, secant squared of what? Secant square of u. But you have to multiply by dx. What's a dx? Negative x squared du. You see, these two would cancel out. The leftover is a negative sign, or just a negative 1. You take it out. So it's going to be negative integral of what? Integral of a secant square of u du. We know that integral of secant square du is tangent. So this is going to be negative tan u, okay, plus the constant c. But we have to substitute for u. U is 1 over x. So the final answer is going to be negative tangent of 1 over x plus the constant c. This would be the final answer. Okay, it's in your book with one of the assignment with the secant square. But sometimes they give you the same one, they change the secant to the sine or the cosine. So be prepared for it. So that would be our type 3 that we talk about it. It can come with a sine, cosine. We have one more, I think is a cosine. So I do that one too. So for trigonometric function, the inside is the one that you're going to call it u to be able to take care of it. Okay, any question? So if you have something similar, it's You have two here. I do the last one first. Let's call this one GH. I do the I, then I come back to the H so that you compare them together. So the last one that you have, it's similar to this, but it's easier. It's integral of x sine of x squared. You see, you can, we did the secant, this is the sine. You can do the cosine, but you cannot do the tangent and the secant for this test. But you will see it next week. So these are the ones that, you should know all of them. But this would be easy. Again, we can do only sine u. This is, you take the u to be x squared. Okay, you take the u to be x squared. And the target is sine u du. You see, when it's a sine, integral of a sine would be negative cosine. Okay, so we find the du, which is a 2x dx. Then you find the dx, which is a du over 2x. Okay, go back, substitute, get the target. So bring it down. We're going to call it I equal to integral of, I don't have anything for the x, don't worry. Sine of what? Sine of u. But you have to multiply by dx. What's a dx? Du over 2x. Now the x and x would cancel out. Left over 1/2. So take out the 1/2. 1/2 integral of a sine u du. And you get your target. You know that you want to find a function whose derivative is sine. That function is a negative cosine. So it's going to be negative 1/2 cosine of u. Let's see. But you have to substitute for u. So that gives a negative 1/2 cosine of x squared. Let's see. And then you're done. This is integral of a sine of x squared x. Very, very popular integral. This and all this type. So if you check the extra 3 that I posted for you, you have one of them over there. So check those. This is one of those type that we're going to be interested. Okay, any question? So that's the 3 types that you see. I see you get one with the radical, or one with the quotient, and one the trigonometric one. But we put them together as 2 questions, 4 parts to integrate for us. There is one before this one. I do that one too, just to have the whole collection together. And this is the one that we did it with the secant, and now it's with the cosine. Again, this one is very popular. See, keep all these solutions for your final exam, I told you. Is the cosine x over 16 plus sine x. All to the 3rd power. You say it's a fractional one, we know that. For the fraction, you have to move it up. Okay, we move it up, and then we do the substitution method. Solution. Move it up. So that gives 16 plus sine x. Everything to the negative 3. At times cosine x, or the other way around, doesn't matter. Cosine x dx. Okay. Then you take this one to be u. So the target is going to be u to the negative 3 du. So that gives you an idea that what you are looking for. In the short form, this is again done in 1 second. You see, your prime would be cosine x is already here. So this would be this to the negative 4 over negative 4. Done. But I do the procedure. So it's going to be 16 plus sine x. That's your u. So we find the du. If of 16 0, there's of sine cosine x dx. You have to find the dx. So the dx would be du divided by the cosine x. That's it. Go back, substitute quickly, that give you to the -3, and then you're done. Okay, move it down here. I equal to integral of, this is simply u to the -3 cosine x times it by the dx. What is the dx? dx is du over cosine x. So these two would cancel out. You arrive at u to the -3 du. Now move up the power, so that gives you u to the -2 over -2 plus the constant c. But you bring the u to the -2 down, so this is going to be -1 over 2u squared plus c. So substitute for u. So that gives you -1 over 2 times u. 16 plus sine x. 16 plus sine x all squared. Plus c. This is going to be the final answer. Okay, so you have a list of all the possibility really for the substitution method. So read it carefully. You should be able to nicely do that 2 problems on this test and the 2 problems on the final. There is no other possibility that I didn't discuss. So study this one carefully. Okay, any question? So we did the 4 questions so far, or we need more. Okay, there are 3 more that to talk about it. And these are going to be definite integrals. See, these are all indefinite. Indefinite is all under derivative. The result is a function. So we introduce a new second integral. Definite integral, the result is a number, and that can be used, for the area problem or some other purposes. So how we're going to handle definite integral. Now, this is going to be the way we are going to do it. We give you one problem, just using the definition to find it. This is going to be very easy problem, very a standard one to get this one through. Okay, so this is going to be number 3. I just do the 3-part 1. Okay, this is number 3. They give you just a power of x. It's going to be a square. In this case, it's cube. It doesn't matter. So we are going to apply the definition. Means no formula. So this question would be definite integral by definition. Apply the definition. The definition of the definite integral to find the following for us. Okay, so this is going to be, yes, apply the definition of the definite integral. Definite integral. Okay, to show that this integral, you see, to show that 0 to 1 x cubed dx to be equal to a quarter. We usually give you x squared, but it's x cubed, doesn't matter. The solution are going to be the same. Okay, this is very standard formula. No formula can you use, only the definition. What is the definition? This is it. By the definition, we mean integral from 0 to 1 x cubed dx is equal to the limit of the sigma of f of ci times delta x. Okay, I from 1 to n goes to infinity. That's it. This is where this is when delta x is equal to the b minus a over n, and the CI. You can bring this formula to your, okay, write down as your, okay, your formula sheet and use it. A plus I delta X. I equal to the 1, 2, up to that. So this is going to be the formula. Step by step, you just make this and prove that it's going to be a quarter. And the way we do it, step one, A is the smaller number, B is the bigger one. So this is the way you do it. A is 0, B is 1. You find the delta X first. Delta X, B minus A over N. B minus over N, it's going to be 1 minus 0 over N, which is 1 over N. 1 over N. So delta X is 1 over N. That is step one. Any question? Step two, CI. CI is A plus I delta X. A is 0. I delta X. Delta X is 1 over N. So that gives you I over N. That's the CI. Step 2. Step 3, F of CI. F of X is X cubed. It's going to be X squared or X cubed. We prefer X squared for the test. Okay, but it's, you know, it's not a big deal. So this is it. So this means F of CI is going to be CI cubed. But what is CI? CI is I over N. Substitute I over N cubed. So that gives you I cubed, N cubed. Okay. So that gives you F of CI. Any question? Next. F of CI. You can do all of them at the, you know, at once. But this is the way I prefer. I prefer to simplify everything first, then go back to inside that, okay, inside that sigma form. So I'm going to bring F of CI delta X. F of CI, I cubed, N cubed. Okay, times delta X, what's delta X? Delta X is 1 over N. 1 over N. Okay, I multiply them together. There is nothing to be simplified. So the top would be I cubed. The bottom one would be N to the 4th. This is F of CI. It's like, you know, when you do those partitioning one, it's like finding the area of one of the rectangles. Now find the sigma. So what's going to be the sigma of F of CI delta X, I from 1 to N? This is going to be the sigma of I cubed over N to the 4th, I from 1 to N. You see, you have to simplify this sigma. Anything other than the I is going to be constant. So if you see anything else, you bring it out. 1 over N to the 4th out. Left over is sigma of I cubed. That's it. This, the problems that we are going to be interested in, you may get sigma I cubed or you may get sigma I squared. So we have to bring these formulas. We already given you the formula, okay? So make sure you bring it, especially sigma I squared. Remember when we talk about the integral, we give you this formula the other day. I just want to show you what was the, this is when we do the definite integral. That's it. These are the formula that you need. So make sure you bring sigma I squared for this test. Okay, sigma I squared is N times N plus 1 to N plus 1 over 6. The one that I'm going to use is sigma of A I cubed. That's the I cubed. N times N plus 1 divided by 2 all squared. So whatever you do, you either get to the sigma I square here for the problems that we have, or you get sigma of I cube here. So sigma I and sigma 1, we have all of them. Okay, you can bring all the formulas, but mostly you need the sigma I squared. So make sure you have it. So in this case, I need to use the I cubed. So I substitute to get that I cubed. Okay, so this is going to be 1 over n to the 4. Now I substitute for sigma I cube, it's n times n plus 1. Okay, divided by 2. And this is going to be all squared. All squared, you simplify that, it's going to be equal to the 1 over n to the 4. So at the top, this is going to be n squared. And this is going to be what? N plus 1 squared. Okay, and this is going to be just 2 squared, which is 2 squared, which is 4. Okay, so this is going to be the case. Simplified if you can. 1 is n squared would be odd. This would be n squared. So the result is n plus 1 squared divided by 4n squared. You see, that's a sigma. So what to do, you take the limit when it goes to infinity and use those shrinking one to get the final answer. You see, we did the sigma, so we have to do the limit. So what's going to be the limit? The limit of n plus 1 whole squared divided by 4n squared. N goes to infinity. Remember, for the limit, we have to shrink it to the leading term. Leading term on the top is n squared, highest power. So it's going to be limit of n squared. And this is going to be 4n squared when n goes to infinity. N squared and n squared will cancel out. You get a quarter. That's it. The integral from 0 to 1, x cubed dx is a quarter. And you're done. Okay, it's easy procedure. Because we are not going to give you a complicated function because we can't do it. If it's going to be complicated, this method is not going to be practical. So just check the one that you have in your extra point is x squared. You do a similar thing, but at the end, instead of sigma I cubed, you end up with the sigma I squared. Sigma I squared is n times n plus 1 times 2n plus 1 over 6. You substitute, simplify, take the limit. So it's a very standard problem, if you like. But we would like to check it. This is the only one that we're using this partitioning one to find it. And we give it 1 on this test, okay? And 1 on the final. Just make sure to bring this formula with you for the, okay, it's part of your formula sheet. You need a sigma I squared for the test. So make sure you have it. Otherwise, it's going to be easy problem. So that's going to be number 3, part 1. You don't need to do the part 2, okay? Because you can check something like, x squared dx. If I get time, I'll come back and explain that one too. But basically, this is going to be the one. Okay? So this is the first question on the definite integral. And the other 2 questions on the definite integral is how we're going to find it. That would be number 4. Okay. So number 4, how are we going to find definite integral by using the formulas? Number 4, would like you to evaluate each definite integral. Okay, we say just integral, but you will see by the way they write it down for you that this is going to be definite. It's going to be 2 parts. Part 1 is ordinary one, that you don't need a substitution method, and the part 2 is the one that you do need the substitution, okay? So that's part 1, ordinary one. 0 to 1, Okay, 3 plus x radical x dx. So it would be one of those problems that we did before. Okay, no substitution is needed. So the only thing that you are going to do is there is a radical here. So you you switch the radical and you just integrate it. So you know that for these type of problems, you have to use the fundamental of calculus. I repeat it. If you want to find this integral, definite integral, you find the antiderivative, we call it f of x. Then you evaluate it from a to b. So this means you substitute for x, f of b minus f of a. There is no constant c, so your final answer is going to be just a number. Okay, so go for it. That's it. Are you ready? To integrate it, we need to change this radical first. Okay, so the solution, we rewrite it. It's going to be 0 to 1, 3 plus x times x to the half dx. X times to the x to the half is going to be 1 plus 1/2, which is going to be 3/2. Okay, so it's going to be equal to 0 to 1, 3 plus x to the 3/2 dx. That's it. Integrate. Integral of 3 is going to be 3x plus x to the 3/2, x to the 1 up, 3/2 plus 1 would be 5/2, divided by the 5/2. No constant c, because this is 0 to 1. So this is the notation that we use. Evaluate it from 0 to 1. You have to simplify it first. 5/2, use the reciprocal. So that gives you 3x plus 5/2 would be 2/5, x to the 5/2. Evaluate it from 0 to 1. So this means you replace the x by 1. That's easy. Replace x by 1, so that gives you 3 plus 2/5. Then minus, open up the parentheses, replace x by 0. In this case, it's easy, 0, 0. So that gives you 0. So you have 3 plus 2/5. Common denominator would be 5. 3 times 5 would be 15. Okay, 15 plus 2, which is going to be 17/5. Okay, so there you are, because this integral is going to be a number. So integral from 0 to 1, 3 plus x radical x dx is simply equal to 17/5, and then you're done. That's part 1 of this question. Any question? Part 1, you may have a fraction, you have to move it up. You may have the radical to rewrite it, but no substitution is going to be involved. That's a part 1. But this problem will have a second part, and the second part is going to be definite integral with the substitution method. So I do the part C. These are the type they are going to be interested in. Part C. Part B is the same, it's too easy. I want to make sure you get time to explain this. Part C. What's part C? Integral from 0 to 13. And that's going to be dx. Okay, dx. And you have the cube root. Okay, cube root of 1 plus 2x all squared. It's a kind of the most general one that you may have with the substitution method. Okay, it's a definite integral 0 to 13. And you have to find the integral first. You know that. There is a radical here. You have to switch it. And at the same time, it's down the denominator. We have to move it up at the same time. Okay, so carefully rewrite it. Solution. So it's going to be 0 to 13. And this would be 1 plus 2x. When it's down the denominator, it's going to be 2/3, but you move it up, negative 2/3 dx. Any question? So that's the important part to just rewrite it correctly. So the bottom one is 1 plus 2x to the 2/3 as a power. And you have to move it up, that gives you negative 2/3. So since there is a parenthesis raised to something, you have to use the substitution method. So for the substitution method, this is going to be u. So your target is going to be u to the negative 2/3 du. When you change it, you must arrive at this. Okay, now the substitution. We do it as we did for the other one. So we get the u. U is 1 plus 2x. That's going to be u. Differential du. Derivative of 1 is 0, derivative of 2x, 2 dx. And the dx. Dx is du over 2. As we did it for all the other problems. But there is something else that you have to do. That is, you see these two numbers, 0 and 13. You see, we change everything from x to the u. So you have to change these two numbers too. There is another method that some people forget. They just keep going, and at the end they do the substitution. But this method is easier. So your extra job for the definite integral is to change these two numbers too. So this is x. You have to change it to the u. Say when x is equal to the 0, what is u? U would be, your substitute here, is going to be 1 plus 2 times 0, which is 1 plus 0, which is 1. So your integral, when you go to the u mode, start with the integral from 1. Okay, then we get the 13. So when x is equal to 13, u would be 1 plus 2 times 13. 2 times 13 would be 26. So that gives 1 plus 26, which is 27. So your u would be 27. So this is the extra job that you're going to have. So when you go back and substitute, you get the u to the negative 2/3 du as you did it before, but these two numbers are not going to be 0 and 13, are going to be 1 and 27. Any question? The other method is forget it, just do as you did it before. At the end, you substitute for u, you see, then come back and get 0 and 13. But if you intend to continue taking calculus 1, 2, and 3, you better do this, because that would be the procedure that we are going to generalize, but it's not a big deal. So go back, substitute everything over here, and then get the result, okay? So I'm going to show you here how we substitute. So this is what you have, 0 to 13. 1 plus 2x to the negative 2/3. This is the original one. Now substitute, equal to. Remember, when u is 0, when x is 0, we get the u, which is 1. When this is 13, we get the u, which is 27. You see, the numbers would be different. This is u to the 2/3, u to the negative 2/3. And we get the dx. Remember, the dx is what? The dx is du over, okay, it's a du over 2. And these are the two numbers that I got. So from 1 to 27, 1 to 27, and the dx du over 2. So dx is going to be du over 2. Nothing to simplify. 1/3 is the number. Take it out. Now integrate. That's it. So this is going to be 1/2 u to the negative 2/3 plus 1. Negative 2/3 plus 1 is like negative 2 plus 3. That gives 1/3. Divided by 1/3. Remember, no constant c. It's going to be evaluated from 1 to 7. You see, you don't have to change it to the x in this method. You can stay with the u because you just want it from at this range, if you like. So use the reciprocal. That give it 3, 1, u to the 1/3 from 1 to 27. So that give it 3/2 u to the 1/3 from 1 to 27. Substitute. So that give it 3/2. U is 27. 27 to the 1/3 minus 3/2. Okay, 1 to the 1/3. You have to simplify this. 27 to the 1/3 is cube root of 27, which is 3. Okay, and this would be just 1 minus 3/2. So we get the 9/2 minus 3/2. So it's going to be 9 minus 3, 6/2, which is equal to 3. So the final answer would be 3. It's a very nice integral. The substitution method in the in the definite integral type. So if we give you one question, 2 parts, as you can see, the first part is ordinary integral. It takes time, this problem. When you want to do it, just manage your time. So in the first part, it's just ordinary one. No use substitution is needed, but for the second part, you do need this one, okay, to get this, okay? So there is one problem regarding the absolute value. We are not going to give you that one in this test. We check it before the final. It's going to be part of your final review. So it's going to be too much for this one. So that would give us time to get to the last problem. Last problem, it's going to be very short and easy problem, but some people, they miss it. And that's regarding the integral function and your differentiation of that number, okay? So this is going to be the last topic, number 5. Integral function, you see? Integral function. You see, we talk about it. Sometimes we have some integral, which is very complicated, and we can do it. We can't find it, but they exist. So we are going to introduce them as an integral function. So the only thing that you need to know is this, that if a function is defined by an integral, you see integral from a to the x, f of t dt, then the derivative of this function, f prime. You see, you want to find the derivative of antiderivative of a function. Derivative of antiderivative of a function is simply function. You drop the integral, replace the t by x. That's it. You don't need anything else. So what we'd like to do is we'd like to give you one of those functions as an integral function and ask you how we're going to operate with this function. How we're going to find the value of the function, how we're going to differentiate it. As soon as we get the derivative, then you may be interested to find the second derivative. So it's not going to be like just the derivative of the function. We wanted to do something for us. So it's going to be of the type C on this problem. The first 2 parts are going to be easy, but we are interested in this form. You see the function? So if this is the problem, if f of x is going to be equal to 2x plus integral from pi half to x, a sine of 2t over t dt. So these are going to be, that integral sine t over t, you can't find it. So that's why we call it integral function. This is given to you, then you ask you to find the following. Find a 3 value. Find f of pi half, value of the function. Find f prime of pi half, f prime of pi half, and find f double prime of pi half. So this is going to be a question we are interested in. We're not going to be interested just differentiate it and leave it. We're going to be interested how we are going to operate with these three. Okay, are you ready? One by one. First one is just a substitution. In fact, this is the first one. Some people, they missed it. Go to the function. Wherever you see the x, replace it by pi half. Okay, so there you are. Solution. F of pi half. Go to the function. 2x, 2 times pi half. Plus, there's the x here. Integral pi half to pi half. Sine of the 2t over t dt. That's it. Now look at the integral part. You see integral from pi half to pi half. We talked about it the other day. If you think about it as an area under the curve, you have to move from A to B to have something. But this is from pi half to pi half. So you don't move, you won't get anything. These integrals are always equal to the 0. So they give you a number so that you can match them together. Otherwise, you can't do it. So if it's going to be starting from the pi half, they give you the pi half. If you start with the 0, they give f of 0. So just focus on the integral part. Integral part is 0. This you simplify. So this would be pi plus 0. Pi plus 0 is pi. So f of pi half is pi. That's the first part. Any question? So for the first part, you have to remember in general, integral from a to a, f of t dt, it's always 0. So as soon as these two are the same, because you don't move, you won't get anything. That's it. Okay, so that would take care of the first part. Any question? Second part, differentiate. When you differentiate, you have to use this formula. So second part, derivative. You have to find f prime of x first, f prime of x. Differentiate. You have 2x2 plus derivative of the integral. We talk about it. Derivative of antiderivative. You drop the integral, replace the t by x. Because the f prime of x is f of x. Derivative of antiderivative of a function is just a function. Okay, it's going to be plus, replace the t by x, so that gives sine of 2x over x. That's it. That's f prime of x. No action, nothing else is needed for this part. But they ask you to find out f of pi half. They may switch the number, but in this case, the same number. Substitute. F prime of the pi half is going to be equal to the 2 plus sine of 2x, 2 times pi half, divided by the pi half. Okay, 2 times pi half would be just pi. So this is going to be 2 plus sine of the pi over the pi half. Sine of the pi is 0. So this part would be 0. 2 plus 0, which is 2. So f prime of pi half is equal to 2. Okay, so for the first part, you have to use this fact that the integral from a to a is always equal to the 0. In the second part, you have to use the fact that when you differentiate an integral, you will lose the integral. So you drop the integral, replace t by x, and the substitute whatever number is given to. That's part 2. Any question? Part 3 is the big one, f double prime. F double prime, you go to the f prime and you differentiate it. You may use, quotient rule. You may have to use the chain rule. So be ready for it, okay? So for the last part, it's the only one that you really differentiate for us, f double prime. Again, you have one nice one in your extra one. Check that one. Okay, you have a couple of them in your lecture notes. Be ready for it. F double prime, you see the derivative of 2 is 0. 0. Less. For this one, you have to use the quotient rule. Derivative of the top times bottom, bottom top. Top. Derivative of the sine is cosine, but it's a cosine of 2x. So you have to multiply by 2. So that gives you 2 cosine of 2x. That's top times bottom times x minus bottom top, derivative of bottom is 1. Times top, derivative is times top sine of the 2x. Divided by the bottom square, x square. That's it. You can simplify, then substitute. There's nothing to be simplified. It's going to be simply 2x cosine of the 2x minus sine of the 2x divided by x squared. So you may have to use chain rule or you may have to use the Gaussian rule. Okay, but where you wanted that pi half. So substitute pi half and get the result. So it's going to be f double prime of pi half. If we give you a trigonometric one, of course, the table is available, or you can use your calculator. And if we won't give you now a trigonometric one, you don't need a table. So this is going to be the case. You substitute the pi half. So that gives 2 times pi half. Okay, let's see if I can put it over here or just continue. So it's going to be 2 times pi half. 2 times pi half cosine of the, okay, it's going to be cosine of the 2 times pi half minus sine of 2 times pi half divided by the pi half square. Pi half square. I will just finish it here. 2 and 2 would cancel out. The sine of the pi half would be 0. So this would be out. This would be cosine of the pi. And this is going to be pi. So I write it down up here for you. F double prime of the pi half. This is what would going to be the leftover on the top. You get the pi cosine of the pi and divided by pi squared over 4. Cosine of the pi is a -1. So that gives you a negative pi over pi squared over power. Just use the reciprocal. It's going to be negative pi times that by 4 over pi squared. So the final answer would be negative 4 pi. Okay, so f double prime at pi half would be simply negative 4 pi. Okay, it's very, very popular problem. You have one in your book where I just give you this and we focus on this type of problems because this is the way you are going to use it in future, not just to differentiate it. So it's a standard problem. So you shouldn't, you shouldn't miss it really. Especially it's a 3 parts. The first 2 parts, something like 6 points out of these, okay, of this problem out of 10, it can be get easily. So for the first part, you just substitute, you focus on the fact that this integral would disappear because it's going to be always the same number. And if there is anything outside, you just take care of it. In the second part is also easy because when you differentiate the outside, but when you differentiate, you lose the integral. So no integral, no derivative, you just substitute. The only part is the third part that you have to differentiate. Depends what you are going to have over here. You may have to use quotient rule or the chain rule. Okay, that's it. I don't have time there. The other one is just they ask to differentiate it, but we are not going to be interested in those type. We are interested in this one. Just take the function and do something for us. Okay, so study your quiz. Okay, I did all these problems because these are going to be part of your final review. but the topics are going to be like this. And check extra 3. That's a very good one for you. Extra 3, give you the model for the second part for the test. Okay, and the first part is going to be your quiz, of course. Study your quiz again. I have only that linear approximation to grade, which is easy to grade, and it will be repeated again. Make sure you don't miss it. Okay, that's it. Any question? So I post this one. If you have any question, let me know. Otherwise, make sure to make your appointment for your test. Okay, test number 3, starting on Monday. We have only 3 sections on chapter 5 that I'm going to do it next week. So by the end of the week, next week, we are done. Then we give you the quiz. You bring back the quiz on Monday. I go over it on Tuesday. So I start reviewing the final review starting Friday. So on Monday, you do the quiz. I just continue with the final review. On Tuesday, I go over the quiz, and there is no class, official class on Wednesday and Thursday to give you time to take your final exam. But I'll be available online. If you have any question, you just let me know. Okay, so this is going to be our plan for the next week and the week coming. Okay, that's it. Let me know if you need anything. Have a good one and take care. Bye-bye.